In his book, Who Owns the Learning?, author Alan November poses the following question. What are you doing in your classroom now that you could turn over to your students to do themselves? This question goes to the heart of Facilitator Standard 2.5. In this presentation, I will be focusing on Designer Standards 2.5a and 2.5b. Because I teach at an all-girls school, projects are developed through the lens of how girls learn, as researched by the National Coalition of Girls' Schools. This includes a focus on collaboration, connection to real-world problems, and building a growth mindset. The project, Designing and Creating Virtual Physics Tours in Google Earth, is completed by students in my senior elective, AP Physics C Mechanics, and addresses two key questions. How do students connect the curriculum to the real world? And how do students connect the curriculum to the school's mission that students challenge, shape, and change the world? The students participate in the AP with We Service Learning Project, in which they engage in service learning activities to strengthen their understanding of AP Physics course material and skills. When we started the project in 2019, the students decided to focus on the issue of improving the public's scientific literacy. We partnered with TalkSTEM, a nonprofit organization in Dallas that focuses on developing future generations of female and underrepresented STEM leaders through a variety of initiatives. The partnership led us to refine our service learning topic to how do we increase the public's knowledge of physics by using public spaces as a teaching tool. One such TalkSTEM initiative is WalkSTEM Dallas, which brings STEM concepts to public spaces in Dallas. K-12 and college students produce 1 to 2 minute videos that highlight a specific STEM concept in their school, nearby park, or institution. So how does the design process work for my students? They identify a local, national, or international location where a visitor could experience physics in a real-life context. They then identify 4 specific stops to highlight 4 different physics concepts in a virtual tour. Finally, they develop a how or why question about the physics at that location. For each stop, students propose a specific concept along with 3 possible questions that a visitor might ask at that location. The biggest challenge for the students? Writing questions that an average person would ask and writing answers to those questions that an average person would understand. Their first iteration received feedback from me, the director of TalkSTEM, and from their peers. After the students received their feedback, they finalized their stops, their questions, and their explanations. Students use the following digital tools. For their initial documentation, they use their mobile devices to capture physics in public spaces during their summer travels. They use Google Earth Tour to create their virtual WalkSTEM tours, and that tour is enhanced by student-produced physics concept videos that are embedded in the Google Earth Tour. This clip is from a WalkSTEM in Paris. The student focuses on the concept of uniform circular motion at a roundabout near the Louvre.
Our first question is about the topic of uniform circular motion and concerns 2 cars traveling around a roundabout. The question states that car 1 circles the roundabout along the inner edge, while car 2 circles the roundabout along the outer edge. Both cars are traveling at the same velocity, but why does it take longer for car 2 to travel around the roundabout? The time it takes to complete one oscillation of a circular track is dependent on 3 main things.
The student projects are assessed on the following ideas: knowledge and explanation of physics, effective use of media, and the connection between physics concepts and the specific location. Students are also required to share their work. Their projects are posted on the project website, shared with the school community, as well as stakeholders such as local chambers of commerce and tourist bureaus.